Very good morning, all. Am I audible? Please let me know. Am I audible? I hope I'm audible. Okay, let us start this session. So, in our today class, we are going to start the second part of our power system, that is fault analysis, stability, and protection. See, in this area, some problems are directly taken from fault, some problems are directly taken from stability, some problems are directly taken from protection. But some problems will be mingled with all these concepts. That's why I have chosen all these concepts together because I cannot separately collect the questions. When I'm talking about fault, immediately I need to talk about protection and stability. They all are mingled together, right? So let us start. Let us go ahead with the first question. First question is what? The most common type of fault that is occur in our Indian power system is dash. That is the first question. I hope many of you know the answer. The most common fault is what? Single line to ground fault. That is the most common fault. See, that is not a dangerous fault when we are comparing it with the three-phase fault. Single phase three phase கூட compare பண்ணும்போது this fault level is less only. பட் அதிகமாக டிரான்ஸ்மிஷன் லைன்ல நடக்கிற ஒரே ஒரு ஃபால்ட் வந்து சிங்கிள் லைன் டு கிரவுண்ட் ஃபால்ட். ஸோ லைன் டு கிரவுண்ட் ஃபால்ட் இஸ் தி கரெக்ட் ஆன்சர். நெக்ஸ்ட், தி மேக்ஸிமம் ஷார்ட் சர்க்யூட் கரண்ட் அக்கர்ஸ் இன் கேஸ் ஆஃப் there are many type of fault in our power system, like a three phase fault, line to line fault, double line to ground fault, line to ground fault. So we have seen there are many fault. Out of all this fault, which fault will provide maximum fault current? Maximum fault current வந்து யார் provide பண்ணுவா அப்படின்னா three phase fault. Okay, fine sir. I hope you all have understood. That is basic theoretical question. Let us go ahead with the next one. In this question, the power system shown in the figure below, the specifications of the components are the following. Generator 1, its correspondent kilovoltage and MVA rating and per unit reactance in percentage given. Then generator 2, its kilovoltage rating, MVA rating, per unit reactance is given in percentage. Similarly, for the transformer 1, rating is given. For the transformer 2, rating is given. Yes, sir. Next, line voltage rating also clearly specified. Now what you need to do is, our task is, what is the question? I think we need to go to the next page. The question is, choose the 25 kilovolt as the base voltage. We have to choose base voltages are V base equal to 25 kilovoltage and voltage, okay, voltage at the generator G1 and the 200 MVA as the base MVA. So the base MVA is going to be 200 MVA. So base MVA is 200 MVA. It was clearly specified in the question. Now the question is, then draw the impedance diagram. Okay. Now we know the base voltage and the base MVA. Let us go back to the question. This is given. What is the base voltage? Base voltage was clearly given as 25 kV kilovoltage, right? So base voltage is given as 25 and the base MVA. MVA base is clearly given as 200 MVA. That's all. Let us draw the single line diagram for the given power system network. It is shown in the diagram. You can see that. And here you can observe there is a mistake in this voltage rating. Actually, the primary voltage must be 220 kilovolt because just now I have been observed the transmission line voltage and the secondary of the first transformer. Same voltage must be appear at the primary side of the second transformer. See there. Here secondary voltage is 220 kilovoltage. Transmission line must be carry the same voltage. Then this transformer primary also must be 220 kilovoltage. Then only it will be matched up. Okay, so the primary voltage of the transformer 2 is not 25, that is 220 kilovolt. Kindly change it. Okay, let us proceed with the question. we need to draw the single line diagram first. How will you draw the single line diagram? First, let us take positive equivalent circuit. First, let us take the single line diagram for the generator G1. Generator G1 and its correspondent per unit reactance. Let me call it as XD. And then we have to consider the transmission line per unit impedance. And then we have to consider the per unit impedance of the transformer 1, not transmission line. And then we have to consider the per unit impedance of the transmission line. First, per unit impedance of the generator, per unit impedance of the transformer 1, per unit impedance of the transmission line, and then per unit impedance of the transformer 2. And then at the receiving end we have one more generator, so per unit impedance of the generator 2. So let me call XD1, let me call it as XD2, and then we will reach the receiving end with the generator equivalent circuit. This is generator 2. That is the complete per unit equivalent circuit. Now here we don't know the value of XD1, XD2, nothing we know, but they have given all the data. Let us proceed one by one. First, let me take generator G1. How will you calculate the new per unit reactance? If you want to know the value of new per unit impedance, then the formula should be the per unit impedance new. I know many of you know the formula, just observe. Per unit impedance new equal to per unit impedance old into what we have to consider, V old divided by V new, base voltages, whole square into MEA new divided by MEA old, MEA new divided by MEA old. That is the formula to obtain the new per unit impedance. Now if you observe our transmission generator 1, already they have given, for the generator 1 the given ratings are V old was given as 25 kilovoltage, comma, MEA volt of the generator. The generator rating was clearly given as 100 MEA, and then per unit reactance. Let me write the Z per unit volt is given as 9%. It means in per unit it will be 0.09. Now what about the new voltages? We knew that is new base voltage. It was clearly specified in the question, 25 kilovoltage and 200 MVA. So new is 25 kilovoltage. MEA new equal to 200 MVA. Now let us substitute all the values in order to obtain the Z per unit or X per unit. In our case we are going to talk about X per unit only. Let me substitute X. No issues. X per unit means then it will become X. That's all. So X per unit volt is 0.09 into V volt, V new, both are same only. 25 kV, 25 kV, 25 kV, it get cancelled. Whole square into MEA new is how much? 200. MEA volt is how much? 100. So it will be cancelled out. These zeros are getting cancelled out. If you multiply it, you will get 0.18. First one. So that is J. We are calculating reactance now. So that J will appear here. Here also you will get the J. So X per unit new for the generator is J 0.18. That is XD1. Coming back to the first one, XD1 is J 0.18. Okay, sir. Let us calculate the second alternator. Go ahead with the second alternator, collect the data. You can proceed with the second alternator and tell me the answer. What it was given for the second alternator? Second alternator means generator. That was given as 25 kilovolt 100 MVA, same. There is no difference between generator 1 and generator 2. So what is the conclusion? If there will be no changes in the ratings, then for the generator 2 also same rating, then what will happen? XD2 also will become J 0.18. There is no doubt. Okay, sir. What is our next target? Transformers. Let us keep our attention with the transformers. In transformer, either you can refer the per unit impedance on the primary side, or you can refer the per unit impedance on the secondary side, because we know the per unit impedance of the transformer is always same on both sides, right? Anyway, let us go from the generator 1 side. Let us take the transformer 1. Transformer 1 kVA rating is given as once again 25 kilovoltage, and MVA rating is given as 90 MVA. If you observe carefully, the rating of the transformer is this is 90 MVA. So MVA volt, and the per unit reactance also given as it will be different. Let us substitute all the values and calculate the value. So this is 25. Let me take that is 90 MVA. This is J 0.12. That is for transformer 1. So transformer 1 and transformer 2 are having same rating. If transformer 1 is having 25, see the transformer 2 also on the secondary side it is having same voltages. So if you calculate the rating of the per unit reactance for the transformer 1, same rating will be considered for transformer 2 also. So let me calculate it for transformer 1. From this again calculate the per unit reactance of the transformer 1 new. It will be equal to J 0.12 volt value into kVA rating. kVA rating of the transformer and given base are once again equal, there is no doubts, into MVA rating. MVA new is 200 MVA, MVA volt is 90 MVA. So it will be equal to, anyway it is getting cancelled out, 10 is getting cancelled out, it will become 20 by 9. So J 0.12 into 20 divided by 9. So what will you obtain if you reduce this? J equal to 20 by 9 only, not 90. Forgive me. So if I will multiply it, 1 minute, we will complete this solution. You can also do it by yourself if you want. I'm doing, give me a minute. 0.12 into 20 divided by, we can directly put, right, 0.2666. So J 0.27 approximately. So what we found is this is J 0.27. Then this is also going to be J 0.27 because the rating of the transformer 1 and transformer 2 is remains same. What about the transmission line? If you observe the transformer carefully, the secondary side rating of the transformer is 220 kilovoltage. So the voltage that is appear on the transmission line is 220. Observe the question carefully. 1 minute guys, let me remove because we don't have space. Transmission line la evlo voltage varum? First transformer oda secondary side second transformer oda primary side both are having 220 kilovoltage, and question la clear mention pannirukanga the rating of the transmission line is 220 kilovoltage only. Of course that is true. Then what we need to do? With that we have to calculate the per unit reactance. Question la enna kuduthirukanga parunga, for the transmission line they had given actual value. Yes sir. So let us talk about transmission line. For the transmission line, given it is actual per unit impedance. Actual per unit impedance is how much? 150 ohm. How will you calculate the actual reactance is given? Per unit reactance, how will you calculate per unit reactance? Per unit reactance equal to actual divided by base reactance. How will you calculate the base value? X base. Sorry. X base or Z base, whatever. Base equal to what we need to do? We have to consider base voltage square divided by MEA base. Correct, sir. It was clearly given in your question itself. How much it is? MEA base is 25 kilovoltage, right? So that is 25 kilo means 10 power 3 whole square divided by base MEA was clearly given as 200 into 1 minute, guys. 200 into 10 power 6. Now calculate the per unit reactance of the transmission line and substitute in your answer. You will get the answer. That's all. So after calculating all these things, what you need to do? You can cross check the diagram. So while calculating, 1 minute, I'm using calci to calculate these values. So the per unit reactance is going to be equal to, why it is wrong? I'm getting some different answer. What happened? Okay, sorry guys, I made a small mistake. Transmission line la what is the voltage? Base voltage is 220 kilovoltage, right? It was clearly given. We cannot consider 25. So for the transmission line, the reactance was given as 220. So what will be the answer now? If you want to calculate the value of reactance, then the formula is going to be, per unit reactance is going to be 220 kilovoltage whole square. Yes, sorry, I made a small mistake. So the per unit value is equal to actual value divided by base impedance, sorry, base voltage, sorry, base impedance only, 220 into 10 power 3 whole square into the 200 will appear in the numerator. Now if you reduce this expression, I am getting J 0.62 per unit. Finally, we got the value. This is going to be J 0.62 per unit. That's all. Here I made a small mistake. Kindly forgive me. Transmission line voltage was clearly given in the question. That is 220 kilovoltage. I took 25 kilovolt. That's why I got wrong answer. Okay. Let us compare it with the options. If you observe what we got for the generator 1 and generator 2. For the generator 1 we got J 0.18, generator 2 we got J 0.18, for the transformer we got J 0.27, right? Whereas this is not for the transmission line, right? For the transmission line we got J 0.62. Any other answers? Here we have okay, and this is also correct, and this is also correct. So the correct answer is option B. I hope you all are getting how to solve this question, right? Yes, sir. Let us proceed with the next question. Okay. அடுத்த questionல என்ன கேட்டிருக்காங்க பாருங்க. The question is, sir, the 25 MVA 33 kilo voltage, okay, 25 MVA 33 kilovolt transformer has a per unit impedance of 0.9. The per unit impedance at a new base 50 MVA and 11 kilo voltage would be dash. That is very simple. Just now we saw the per unit impedance, new per unit impedance equal to Z per unit volt into Z per unit volt into V volt divided by V base new whole square into MEA base new divided by MVA volt. That's all. Substitute பண்ணலாமா? Z per unit volt is given as 0.9 into V volt. V volt is 33. V new is how much? 11 whole square into MVA new is 50. MVA volt is 25. Reduce பண்ணங்க, you will get 0.9 into, it will be 3 times. 3 square will become 9 into, it will be 2 times. So 2 times of 9 is how much? First of all, 1 minute guys. Okay. 9 into 9 is how much? First of all, it is 81. 81 to 2 will become 162. So it will become 16.2 per unit. That is Z per unit new. Correct? So what is the correct answer? Option D is the correct answer. Let us go ahead with the next question. அடுத்து என்ன கொடுத்திருக்காங்க பாருங்க. In our question, next case is a 75 MVA 10 kilovoltage synchronous generator has the direct axis reactance, that is synchronous reactance, is 0.4 per unit. The value of the XDN per unit to the base MVA 111 kilovolt. Same formula, no? Just now we saw the formula is what? Just register it into your brain. X per unit new equal to, once again, X per unit volt into V volt divided by V new whole square into MVA new divided by MEA volt. That's all. Substitute all the values, you will get the answer. Let me move on to the next question. So the next question is, 1 minute guys. Fine. So the next question is what? The one line diagram of a simple power system given below. The transformation ratio of the step up transformer is given as 11 by 220 kilovoltage. The base MVA is 100 and the base kilovoltage is 11 on the generator side. Where is generator? This is the generator. So here the base voltage of the transformer is given as 11 kilovoltage. Now the question is, what is the base voltage on the transmission line side? In this side, what will be the voltage? That is very simple. If you want to know the base voltage on secondary side or transmission line, what you need to do? Very simple. Base voltage on primary side, first step. The formula is base voltage on primary side into transformation ratio. That is secondary voltage divided by primary voltage. You have to substitute. that is transformation ratio. Primary voltage is 11 kilo voltage, secondary is 220 kilo voltage divided by 11 kilo voltage. 11 getting cancelled, so the new kilo voltage will become 220. Just to transform the secondary side voltage, that will be directly considered as the base voltage for the transmission line. நம்ம முன்னாடி calculate பண்ணோம் இல்லையா, நம்ம ஒரு problem solve பண்ணோம் இல்லையா, so இந்த problem solve பண்ணும்போது transmission line ஓட reactance நம்ம calculate பண்ணோம், per unit reactance of the transmission line. While calculating the transmission line per unit reactance, I have not considered the given 25 kilo voltage. Why? Because in the transmission line, the base voltage was specified as what? 220 kilo voltage for the transmission line. So directly I have taken actual divided by base. For the base, what I have done? 220 has been considered as the base voltage. Because we are shifting our value. So far we are considering 25. Generator la 25 consider பண்ணோம், transformer க்கு 25 consider பண்ணோம். Transformer ஓட primary ல இருந்து secondary போகும்போது rating of the transformer is getting different, so that will be injected into the transmission line. So the new base voltage will become 220 kilo voltage. You have to calculate the per unit reactance of the transmission line for the given base voltage or secondary base voltage of the transformer. So here also they are asking the same question. Transmission line la base voltage வந்து என்ன consider பண்ணுவீங்க அப்படினு கேக்குறாங்க. Generatorல இருந்து பாக்கும்போது from the point of generator the voltage is 11 kilo voltage, but when we are entering into the secondary side of the transformer, the rating of the transformer voltage will become 220 kilo voltage. That voltage only will be injected into the transmission line, so the base voltage of the transmission line will become 220 kilo voltage. What is the correct answer? Option B. Sir, don't get confused with this root 3, these things at all. Actually, we are considering transmission line la கொடுத்திருக்க parameter வந்து எதுக்கு கொடுப்பாங்க அப்படின்னா, they will consider line voltages தான் கொடுத்திருப்பாங்க. Transformation ratio, turns ratio வந்து lineல தான் இருக்கும் in terms of. So directly நீங்க என்ன பண்ணிக்கலாம், அப்படியே line voltage அப்படியே எடுத்து போட்டுக்கலாம். You don't need to consider that root 3 bluff stories at all. Now the next question is, read the next one. Next question, a 10 kVA 400 by 200 voltage single phase transformer with a 10% impedance draws steady state short circuit current of dash. Okay, that is very simple question. Let me proceed. First என்ன கொடுத்திருக்காங்க, short circuit current எவ்வளவுன்னு கேட்டிருக்காங்க. Rating of the transformer is given as 10 kVA, 400 voltage, that is on HV side, divided by 200 voltage on LV side. The transformer has percentage impedance or per unit impedance of 0.1 or 10%. Now the question is, find out the steady state short circuit current. Steady state short circuit current is how much? That is, secondary side of the transformer is getting short circuited. Under this situation, அப்ப என்ன ஆகும், பிரைமரில இருந்து எனார்மஸ் அமௌண்ட் போகும் இல்லையா, அதோட வேல்யூ வந்து என்னன்னு கேக்குறாங்க. அப்ப per unit impedance எவ்வளவு கொடுத்திருக்காங்க? 0.1 in per unit, or you can consider it as 10%. Okay, let me tell you one logic here. First one, you can say the, இப்போ நம்ம என்ன பண்ண போறோம், secondary side யூசுவலா என்ன ஆகும்னா ஷார்ட் சர்க்யூட் வந்து நம்ம கால்குலேட் பண்ணும்போது secondary side will be short circuited. ஷார்ட் சர்க்யூட் கரண்ட்னால secondary short circuit ஆயிட்டு இருக்கும், பிரைமரில இருந்து எவ்வளவு கரண்ட் போகுது அப்படிங்கறதா question. Now in order to catch up that value, what we need to do is, we know the voltage drop, per unit impedance வந்து 10% கொடுத்திருக்காங்க இல்லையா, voltage drop is directly proportional to percentage impedance. Okay, that is எவ்வளவு percentage impedance இருக்கோ அவ்வளவு percentage voltage தான் அதுல drop ஆகும். Both are directly proportional according to Ohm's law. V is equal to I into Z. So V is directly proportional to Z. If Z is 10%, then per unit value of voltage also, it is also going to be, voltage also going to be 10%. That's all. Z value is 10%, then voltage also going to be 10%. Now tell me, what is the 10% of this 400 voltage? Secondary side is short circuited, so that voltage you don't need to consider. 10% of 400 is how much? 10% of 400 is, that will be 10 into 400 divided by 100. So these two zeros are getting cancelled. It will be 40 voltage. That is the available voltage now. Now we have to calculate the short circuit current by using rated kVA is given as 10,000. That is 10 kVA divided by voltage. We know apparent power is equal to V into I conjugate. Magnitude will be V into I only, just when we consider the magnitude alone. So by from this short circuit current equal to apparent power divided by voltage rating. Voltage rating is only 40. So 10 is getting cancelled out. If I will cancel it, it will become 25. So the answer will become 250 ampere. That is the short circuit current. Okay, sir. That is one way. Now, according to the given rating, rated kVA value is 10 and primary voltage is 400 divided by secondary voltage is 200. Yes, sir. And the per unit impedance in percentage, it was given as 10 percentage. That is clearly given. In order to calculate the short circuit current, first calculate the actual current. If you want to know the actual current, you have to take 10,000 actual voltage divided by base voltage. Actual current means actual kVA rating divided by actual voltage. In this case, what will you obtain? If I will cancel it, I will get 100 divided by 4 will become 25 ampere. Then to obtain the rated short circuit current, you have to divide actual current divided by per unit impedance. Not in percentage, just you have to substitute the actual per unit impedance. Actual current is 25 divided by per unit impedance is 0.1. Then also you will get same 250 ampere. There will be no changes. Either you can follow the previous one or this one. First you have to understand, that's all. So what is the finalized conclusion here? Anyway, in both cases what we got? We got the same answer. There is no changes. Correct answer is option C. Okay, sir. Let us go ahead with the next question. Given it is a transformer rated for 500 kVA, 11 kilovolt, 0.4 kilovolt has an impedance of 10 percentage once again, and it is connected to an infinite bus. Now the question is the fault level of the transformer is dash. What is the fault level MVA? That is the question. What will be the answer? Anyone? Can you guess this? Can you guess the answer? This is very simple question only, but I need all of your attention. Just tell me what will be the correct answer. Nobody is getting the answer. Let me tell you. This is one step formula. Fault level MEA. Fault MEA equal to actual MEA divided by per unit impedance. இப்போ நம்ம கரண்ட்டுக்கு போட்டோம் இல்லையா அதே தான் percentage per unit impedance we have to substitute the per unit value, right? So what will you obtain? Actual MEA is given as 500 kVA divided by per unit impedance is 0.1, so it will become 5000 kVA. இப்போ நம்ம முன்னாடி எழுதணும் இல்லையா short circuit, that is fault current equal to actual current divided by per unit impedance. We got the answer. Same here, I done the same thing. Here also I am doing the same thing because MEA rating is directly proportional to current. Whatever the relation that we are using for current, it will be applicable for MEA rating also. Fine, sir. Let us go ahead with the next question. What is this? Only diagram is there, data is missing. VAB leads VB something they had given. Diagram question விட்டாங்களே. Okay, right. Let me take, there are two possibilities. Either they may ask you to calculate the positive sequence network or negative sequence. Let me draw both. See what it was given. Given it is a star connected and a delta connected network. Primary is star connection, secondary is delta connection. Yes or no? Primary is star connection. Observe the circuit carefully. Primary is star connection. It has been drawn like this, right? So they are taking A, B, C. So this is star connected network. Secondary is delta connection. Secondary in delta connection. Okay. So that is also given as what they are considering A, B, C. So that is secondary is delta connection. So what it was given, star delta. Now the question is VAB leads VB by 60, 30 degree அந்த மாதிரிலாம் கொடுத்துருக்காங்க இல்லையா, that is what vector group, three phase transformer vector group. How will you calculate the how will you find out identify the three phase transformer vector group? In vector group there are generally four groups, either it is under 0 degree or 180 degree or plus or minus 30 degree, that's all. Plus 30 minus 30. Anyway, in your examination you cannot expect the question from these two. Only these two questions will be asked in the examination, because that is direct question. If they will give you star star or delta delta, simply you can drop your answer. So they won't ask the question from here. Question will be taken for the plus or minus 30 degree. Okay, sir. Anyway, I hope you all know how to draw the diagram. Let me draw the diagram first, such that you will get the clear idea. Plus or minus 30 degree யாருக்கு வரும்? Plus or minus 30 degree will be for star delta delta star. 0 degree or 180 degree யாருக்கு வரும்? Star star delta delta. Same winding. Primary star, secondary star, primary delta, secondary delta அந்த மாதிரி வந்ததுன்னா you will get 0 degree or you may face 180 degree. When primary is star, secondary is delta, or primary is delta, secondary is star, in that case what will happen? That case will be different. Right, sir? So let us see. Okay. இப்போ நம்ம கேஸ்ல என்ன கொடுத்திருக்காங்க? பிரைமரி ஸ்டார்ல கொடுத்திருக்காங்க. ஓகே, வெக்டர் குரூப் ஸ்டார்ட் பண்ணலாமா? நான் என்ன அஸ்யூம் பண்ணிக்கிறேன் அப்படின்னா, ஃபர்ஸ்ட் இட் இஸ் பாசிட்டிவ் சீக்வன்ஸ். பாசிட்டிவ் சீக்வன்ஸ் அப்படின்னா பிரைமரியும் ஏபிசி தான், செகண்டரியும் ஏபிசி தான். நெக்ஸ்ட் நெகட்டிவ் சீக்வன்ஸ். நெகட்டிவ் சீக்வன்ஸ்னா இதுக்கு ஆப்போசிட் கேஸ், ஏசிபி ஏசிபி. So positive sequence means normal sequence. First phase A will appear, A1 will be in the neutral point, A2 will appear outside, and then phase B will appear, B1 will be inner, B2 will be outside, and then C1 will appear, C2 will appear in the outside. That is star connection, right sir? Primary star. Secondary இப்போ டெல்டாவுக்கு வரையணும். நமக்கு என்ன தெரியும் அப்படின்னா, பிரைமரியோட ஃபேஸ் லைன்ஸும் செகண்டரியோட ஃபேஸ் லைன்ஸும் parallel to each other, அதுல டவுட்டே இல்லை. இப்போ செகண்டரியில நான் ஃபேஸ் ஏக்கு வரைஞ்சேன் அப்படின்னா, let us say that will be A1 to A2. See there, பிரைமரியோட ஃபேஸும் ஃபேஸ் ஏவும் செகண்டரியோட ஃபேஸ் ஏவும் parallel வந்துருச்சா? எஸ் சார். நெக்ஸ்ட் ஃபேஸ் பி இப்படி இருக்கா? இதுக்கு parallel-ஆன லைனை இங்க நான் வரையணும். See there, first of all if you observe the question carefully, this is face A. When I will consider it as, இப்போ நான் A1 A2 அப்படின்னு நான் consider பண்றேன் அப்படின்னா, it will be considered as B1 B2. Similarly, I have to consider it as C1 C2 outside appear ஆகும்போது. கரெக்டா சார்? எஸ். இந்த 3 நெட்வொர்க்கே வந்து நம்ம ஒண்ணா இன்டர்கனெக்ட் பண்ணணும். அடுத்து நம்மளோட டார்கெட் என்ன அப்படின்னா, பியும் ஏவும் வந்து பேரலா வரணும். ஆனா செகண்டரி வந்து டெல்டா ஸ்ட்ரக்சர். டெல்டா ஸ்ட்ரக்சர் அப்படின்னா இந்த மாதிரி ஃபார்மேட்ல வரணும். இப்படி வரலாம், இல்ல இப்படி வரலாம். ஆக மொத்தம் டெல்டா இப்படி வரணும். ஓகே சார், ஃபைன். அப்போ பி பேரலா வரணும் அப்படின்னா எய்தர் ஐ கேன் கீப் ஹியர் ஆர் ஐ கேன் கீப் ஹியர். பட் இங்க நான் வச்சேன் அப்படின்னா டெல்டா வராது. ஐ ஹாவ் டு கீப் ஹியர். ஸோ இட் இஸ் கோயிங் டு பி வாட்? B1 to B2. நெக்ஸ்ட் சிக்கு பேரலான லைன், இதுக்கு பேரலா வரையணும்னா இங்க வரைஞ்சிக்கலாம். கரெக்டா? ஸோ டெல்டா அப்பியர் ஆயிடுச்சா? டெல்டா சர்க்கியூட் வந்துருச்சு. தட்ஸ் ஆல். இப்போ நீங்க என்ன பண்ணிக்கலாம் அப்படின்னா, இப்போ நான் பிரைமர்ல என்ன பண்றேன் அப்படின்னா, சிக்கும் பிக்கு நடுவில் ஃபேஸ் ஆங்கிள் எடுத்துக்கிறேன். சப்போஸ் I'm measuring the voltage between C to B2. இங்க வோல்டேஜ் C to B2 நடுவுல எங்க இருக்கு பாருங்க. This is the voltage. அப்ப லைன் எப்படி வருது பாருங்க. So if you observe it carefully, C2 க்கும் B2 க்கும் ஸ்ட்ரைட் லைன் இப்படி வருது. செகண்டரியில C2 க்கும் B2 க்கும் லைன் இப்படி வருது. இதான் கிளாக். இது அப்படியே கிளாக்கா மாத்துங்க. இது அப்படியே கிளாக்கா மாத்தணும் அப்படின்னா, பிரைமரி வந்து HV வைண்டிங். அது எப்பவுமே என்ன இருக்கும்? 12 o'clockல ஃபிக்ஸ் பண்ணிடுவோம். செகண்டரி இங்க எங்கேயோ இருக்கு பாருங்க. only two cases possible. either 30 degree laggingல வரலாம், இல்ல leadingல வரலாம். clockல இது 12 o'clock அப்படின்னா இதுக்கு முன்னாடி இங்க இருக்கிறது என்னது? 11 o'clock. அப்போ what is the phase angle difference between the primary and secondary? 30 degree. secondary lead பண்ணுதா இல்ல laggingல இருக்கா? if you observe it carefully, let me keep it here. இது primary. secondary இப்படி இருக்கா? so the conclusion is secondary leads primary by 30 degree. I can say VAB leads, small VAB leads capital VAB by 30 degree. இது positive sequence network தான். இதே வந்து நம்ம நெகட்டிவ் வரைஞ்சோம் அப்படின்னா, how will you draw the negative sequence? Let me draw. If you want to draw the negative sequence, once again first draw A1 to A2 primary star connection. நெகட்டிவ் சீக்வன்ஸ் அப்படின்னா ஏக்கு அப்புறம் யார் வரணும், சி வரணும். அப்ப இங்க யார் வருவா, C1 to C2 and then B will appear, B1 to B2. that is for negative sequence. செகண்டரியில லைன் எப்படி வரணும், பேரலா வரணும். இப்போ பிரைமரிக்கு செகண்டரி வந்து டெல்டா கனெக்ஷன்ல வரையணும், பிரைமரி ஸ்டார். இப்போ டெல்டாவில் ஃபர்ஸ்ட் லைன் A1 to A2 பிரைமரிக்கு பேரலா வந்துருச்சு. அடுத்தது இப்போ நம்ம யாரை வரையணும், சி வரையணும்னு வச்சுக்கோங்க. சி வந்து பேரலா வரணும். யாருக்கு பேரலா வரணும், ஐ மீன் பிரைமரியோட ஃபேஸையும் செகண்டரியோட ஃபேஸையும் பேரலா இருக்கணும். அதே மாதிரி பிரைமரியோட ஃபேஸ் பியும் செகண்டரியோட ஃபேஸ் பியும் பேரலா இருக்கணும். வேர் கேன் ஐ கீப் திஸ் ஒன், இது அப்ப நம்ம சிக்கு வந்து பேரலா வரையணும் அப்படின்னா ஹியர் ஃபர்ஸ்ட் சி வில் அப்பியர். So it will go from C1 to C2 and then you can keep B. You can go from B1 to B2. So what is the conclusion here? So in this case, what I have drawn? I have taken first A and then I have taken C and then I have taken B. That is reverse connection. Why? Because here in the question given data is what? Negative sequence. In our previous case, oh, I have been removed that, right? Previous case நம்ம என்ன பண்ணிருந்தோம், in previous case I have taken A1 here, A2 here, and then I have taken B1 here, B2 here, and then I have taken C1 here, C2 here. Correctness sir? Yes. இப்போ இந்த கேஸ்ல என்ன பண்ணிருக்கோம், just we have been reversed this case. If you again observe, அப்ப நம்ம இதை reverse பண்ணிட்டோம் அப்படின்னா delta connectionல என்ன ஆகும், phase will be reversed. First we are going from A1 to A2 and then we are considering C1 to C2 and then we are considering B1 to B2. Now here the connection is either you can draw in this way or you can draw A1 to A2, yes sir, and then it will appear C1 to C2 and then this is also correct. Small, right, use small letter, B1 to B2, use small letter. இப்போ இந்த ரெண்டு டயக்ராம்ல எந்த டயக்ராம் சார் கரெக்டா, எதர் இது கரெக்டா இல்ல இது கரெக்டா, this confusion will appear for all of you guys. அப்ப நீங்க என்ன பண்ணணும், in that case you have to draw the diagram. கொஸ்டின்ல ஒரு டயக்ராம் கொடுத்திருக்காங்களே, அந்த டயக்ராம் வரைஞ்சிட்டோ then if you proceed you will get the clarification. கொஸ்டின்ல என்ன டயக்ராம் கொடுத்திருக்காங்க அப்படின்னா, let me draw the diagram. Primary it will be given like this. Yes sir. இப்போ ரெஃபரன்ஸ் வந்து நம்ம என்ன எடுத்துக்கிறோம் அப்படின்னா A2 B2 C2, inner it is A1 B1 C1. அதே மாதிரி டெல்டா வரையறீங்க அப்படின்னா what we need to do is you have to draw the delta connected winding. 1 minute. Okay, let me draw like this, no issues. இப்போ delta connected winding வரையறோம் அப்படின்னா first you should again I have to keep A2 B2 will appear here, C2 will appear here. Sorry, use small letters. A1 will appear here, B1 will be here, C1 will be here. There is no doubts. நம்ம அடுத்து என்ன பண்ணோம் அப்படின்னா we should draw the sequence in a proper way. இப்போ கொஸ்டின்ல வந்து ஃபர்ஸ்ட் என்னென்ன கொடுத்திருக்காங்க பாருங்க. If you observe, 1 minute, I will draw. See, this is A2, A1 will appear here, this is C2, inner C1 will appear, and then what will happen, this is B2, B1 will appear here. Correct? If you join these 2 points, see there, internally this is the phase. In this phase we have to consider A2 ல start பண்ணி we are உள்ள எங்க முடியுது, per phase க்கு நம்ம போகும்போது A1 ல முடியும். So C2 ல start பண்ணோம் அப்படின்னா internally it will going to be terminated into C1 and then B2 ல start பண்ணோம் அப்படின்னா it will be going to be terminated to B1. Now if you draw the same structure here, again I have to follow. See, this is A1, right? அடுத்து எங்க ஸ்டார்ட் ஆகுது பாருங்க, A1 to A2 போறீங்க அப்படின்னா and then A2 will be connected with the 1 minute guys. A1, if you take A1 again, in order to form the delta structure here, let me come back here. இப்போ இது either எந்த ஸ்ட்ரக்சர் வரலாம், it will be connected like this, it will be connected like this, and then what will happen, this will be connected here. இப்போ இந்த மாதிரி கனெக்ட் பண்ணீங்கன்னா A2 will be directly connected with the C1 and then what will happen, B2, this is B2, B2 will be connected with the A1 and then C2 will be connected with the B1. So either you may get this structure, இல்லனா இன்னொரு ஸ்ட்ரக்சர் என்ன வரும், நெகட்டிவ் சீக்வென்ஸ் கொடுத்தாங்கன்னா ஆப்போசிட் ஸ்ட்ரக்சர்ல வரும். So this things will be mentioned in your examination. இப்போ அந்த மாதிரி கொடுத்துட்டாங்க அப்படின்னா what you can do, டைரக்டா நீங்க என்ன பண்ணிக்கலாம் அப்படின்னா only two possibilities தான் வரும். either it may be leading or lagging. ஸோ இதுல எந்த டயக்ராம் கொடுக்குறாங்கன்னு பாருங்க. either இந்த ஸ்ட்ரக்சர் கொடுக்கலாம், அப்படி இல்லைன்னா ஆப்போசிட் ஸ்ட்ரக்சர் கொடுப்பாங்க. ஆப்போசிட் எப்படி வரைவீங்க? லைக் திஸ். That's all. So இத வரைஞ்சு நீங்க என்ன பண்ணிக்கலாம்? You can draw the phase sequence. So anyway, coming back to the conclusion, நம்ம questionல just இந்த diagram மட்டும் தான் கொடுத்திருக்காங்க, and one more thing, some data is missing, right? I am going up with my own data. Last case நம்ம என்ன பார்த்தோம்னா positive sequenceக்கு வரைஞ்சோம். When we are drawing it for negative sequence, this case will be opposite. Positive sequenceக்கு நம்ம இந்த பக்கம் போயிருந்தோம். Positive sequenceக்கு நம்ம எங்க இருந்து ஸ்டார்ட் பண்ணோம்? We should start from A and then C and then B. Same sequence. I have to start from A and then I have to reach C and then I have to reach B. So அப்ப positive sequence க்கு நம்ம first வரைஞ்சப்ப we got the diagram like this, right? அப்ப negative sequence க்கு இதுக்கு opposite ல வரும். That's all. Negative sequence க்கு opposite ல வருது அப்படின்னா if you draw the line in between B and C, you will get the line like this. அதே மாதிரி இங்க B க்கும் C க்கு நடுவுல லைன் வரைஞ்சீங்க அப்படின்னா you will get the line like this. See there, it is here. So it will be here. அப்ப என்ன வரும் அப்படின்னா lagging வரும். யாரோ secondary voltages lags the primary voltage. That's all. I hope I have spent a lot of time here. So finally, let me come to the conclusion. See, first case என்ன அப்படின்னா when we are considering positive group, what we got, it was leading. Secondary is leads the primary. Secondary is small VAB leads capital VAB by 30 degree. If you go up for the second case, what will happen? This is primary, this is secondary. Secondary lags primary by 30 degree. That's all. That is the case number 1. This is for positive sequence, this is for negative sequence. Some of you may not clearly observe what I was trying to conclude. Please go through the lecture once. There will be no point of having doubts. I have clearly taught you because இங்க நான் எல்லாத்தையும் explain பண்ண முடியாது. It will consume lot of time. Okay. நான் ஒரு சில பாயிண்ட் விட்டுருக்கலாம் because that is under lecture. Please go through the lecture. No issues. There I taught everything clearly. Take the next one. Two generators J1 and J2 are connected by 15 kilowatt line with the bus at the midpoint shown in the figure. Now the question is, G1 is 250 MVA 15 kilovolt positive sequence reactance of 25% MVA, per unit reactance. Similarly, for the generator G2 100 MVA 15 kilovolt per unit reactance is given. Transmission line length is given and the reactance is given. See, what they given once again, actual value கொடுத்திருக்காங்க transmission line க்கு 0.225 per kilometer. Total kilometer எவ்வளோ 10. அப்ப இதை 10 ஆல மல்டிப்ளை பண்ணீங்கன்னா you will get 2.25 kilometer. 2.25 ohm for 10 kilometer. That is the total value. So net reactance, net actual reactance will become 2.25 ohm. ஏன்னா total length of the transmission line 10 kilometer கொடுத்திருக்காங்க. அப்ப reactance எவ்வளோ வரணும்? Per kilometer க்கு 0.225 னா 10 kilometer க்கு 2.25. 10 ஆல மல்டிப்ளை பண்ணிக்கோங்க. First conclusion is over. அடுத்தது, you all know how to calculate the per unit values. Just now I taught you. Just proceed. Take generator 1. First let me draw the equivalent circuit. Generator 1, it is connected with the ground. It will offer positive per unit reactance. Let me consider it as XD1. And then transmission line 1 will offer some reactance XT1. And then transmission line 2 will offer some reactance XT2. And then generator 2 will offer some reactance XD2. There will be no transformer in our line, so we don't need to be bothered about the transformer. That's all. Shall we proceed now? Yes. Let us consider generator 1. XD1, that is new. XD1 new equal to XD1 volt into, what is the formula? The formula is V volt divided by V new whole square into MEA new divided by MEA volt. Substitute all the values, you will get the reactance. XD dash volt was given as 0.25. Yes sir. Volt எவ்வளவு கொடுத்திருக்காங்க? V voltage எவ்வளவு கொடுத்திருக்காங்க? So in our case number 1, I think yes, given it is 15 kilo voltage and the base voltage 15 kilo voltage தான். Questionல first கொடுத்துட்டாங்க. Into MEA new 100 MEA. 100 MEA. MEA volt எவ்வளோ? 250 MEA. Observe the question carefully. MEA new வந்து 100 MEA last கொடுத்துருக்காங்க பாருங்க diagramல. Last statement. It is here. Observe it carefully. Right? So, per unit impedance on 100 MEA common base. That is the question. Fine, sir. Reduce பண்ணுங்க. Anyway, it will be cancelled out. It will become 0.25 into 10 is getting cancelled out into 10 divided by, or you can do one thing. 100 into 25 is how much? 100 into 0.25 will become 25 divided by 250. 25 divided by 250. It will become 10 times, or I can say 0.1, j 0.1. So this will be equal to 0.1, j 0.1. First one is over. Next, sir, if G1 is j 0.1, what about G2? G2 having different rating. In this case, G2 ஓட வேல்யூ என்னென்ன கொடுத்திருக்காங்க பாருங்க. G2 க்கு வந்து வோல்டேஜ் வந்து சேம் ரேட்டிங் தான். ஆனா MEA volt is 100. MEA volt is 100. MEA new 100 தான். அப்ப டைரக்டா இதுவும் கேன்சல் ஆயிடுமா? So you will get only J 0.25 once again. So the conclusion is, if you take the, okay, reactance is different. 1 minute guys. For generator 2 எல்லா டேட்டாவுமே மாத்திட்டு இருக்காங்க. I will do it properly. Solve பண்ணுங்க, substitute பண்ணுங்க values now. For generator 2, MEA actually given as 0.1 only into this is 15 by 15 whole square into this is 100 by 100. So everything is cancelled out. Again we are going to get J 0.1 only. So what is this? This is also J 0.1. Now let us focus on transmission line. Transmission line la enna kuduthirukanga? They had given only actual reactance. In transmission line, actual reactance is given. Then how will you calculate the per unit reactance? You know how to calculate the per unit reactance. I already taught you. The per unit reactance equal to what we need to do? Actual reactance divided by base impedance. So this is going to be actual reactance divided by base impedance equal to V base square divided by MEA base. It will be equal to, since transmission line oda reactance, sorry, transmission line oda voltage வந்து செப்பரேட்டா கொடுக்கல, அப்ப டைரக்டாவே நம்ம என்ன எடுத்துக்கலாம்? 15 கிலோ வோல்டேஜ் தான் அங்கே இன்ஜெக்ட் ஆகுதுன்னு எடுத்துக்கலாமா? சேம் 15 கிலோ வோல்டேஜ். see நம்ம என்டையர் சர்க்யூட்லயும் 15 கிலோ வோல்டேஜ் தான். ஜெனரேட்டர் 1 க்கு ஜெனரேட்டர் 2 க்கு காமன் எல்லாமே 15 தான். So we can directly take actual reactance is 2.25 divided by, this is 15 square into 10 power 3 square, that will become 10 power 3. 15 kilo voltage whole square, it will become 15 square into 10 power 6 into MEA base. This numerator vandruma, that will be 100 into 10 power 6. Anyway 10 power 6, 10 power 6 getting cancelled out. Reduce this, it will be 2.25 divided by 15 square will become 225 into 100. This 100 multiple பண்ணீங்கன்னா என்ன வரும்? Again 225 getting cancelled out. I am getting J1. See, that is the transmission line reactance, but they have given two transmission line. This is transmission line 1 reactance, this is transmission line 2 reactance, but ரெண்டுமே equal அப்படினு சொல்லிட்டு questionல கொடுத்திருந்தாங்க. So you are going to get J1 per unit only. Here also J1 per unit only. Now what is the correct answer? I think option A wa. This is J 0.10, J 0.1, J1, J1. Yes, that is the correct answer. So option A is the correct answer. Let us go ahead with the next question. அடுத்து என்ன கேட்டிருக்காங்க பாருங்க. In the above system, previous question. In the above system, the three-phase fault MEA at bus 3 is dash. Very good question. Let us take the same question. Where is the question? This is the question. This diagram we want. Okay. Okay. Let me draw it first. Okay. This is generator G1. This is generator G2. First you must think. This is J 0.1 per unit, J 0.1 per unit, J1 per unit, J1 per unit. The question என்ன கேட்டிருக்காங்க? Where is bus 3? According to the given diagram, நீங்க options observe பண்ணுங்க. ஆப்ஷன்ல clear மென்ஷன் பண்ணிருக்காங்க பாருங்க. This is bus 3, middle point. அதாவது இந்த இடத்துல தான் fault நடக்குது. This is the fault point. அந்த இடத்துல fault வந்துருச்சு அப்படின்னா fault level MEA ஓட வேல்யூ வந்து எவ்வளவு வரும் அப்படிங்கறத क्वेश्चन. How will you solve it? Just to think, it is normal question and you can solve it by yourself. You no need of my help. If you try a little bit, you will get the answer. Anyway, let me solve it. That is my responsibility. இங்க தான் fault நடக்குது. அப்ப என்ன நடக்கும்? See there, when there is a fault suddenly, அப்ப இங்க இருந்து என்ன வரும்? You can observe two fault current. One is from this generator you will receive one fault current. Let me call it as fault current 1. This generator will supply ரெண்டுமே என்ன பண்ணும்? இந்த இடத்துக்கு fault current supply பண்ண ஆரம்பிச்சிடும். So the net fault current equal to sum of fault current supplied by the generator 1, fault current supplied by the generator 2. But luckily, if you observe, the property of generator 1 is identical to the property of generator 2. Both are having same data. So I can say fault current 1 and fault current 2 both are equal. So twice of fault current 1 or fault current 2. ரெண்டுமே ஈக்குவல் தான். நீங்க ரெண்டுத்துல ஏதாச்சும் ஒரு கரண்டை கால்குலேட் பண்ணாலே you will get the answer அப்படின்னு சொல்லுவாங்க. How will you calculate the fault current? See, we are calculating all the values in per unit. While calculating the per unit, free fault voltage will be considered as 1 per unit. Voltage will be considered as 1 per unit, we all know. Now, let us calculate the fault current from the first case, IF1 for this generator. Voltage total voltage supplied by the generator is 1 per unit divided by total reactance offered by the transmission line up to fault point. எவ்வளவு இருக்கு? J0.1 plus J1. So it will be equal to 1 divided by 1.1 J. Am I right, sir? What is the value of 1 divided by 1.1? It will be 0.9, but minus J 0.9. So same current will be appear for second. From here also you can get the same current. But total fault current எவ்வளோ? Twice of fault current minus J 0.9. Total fault current and 2 all multiple ஆகுது. Two generators, generator 1 and generator 2. Both are supplying same current. So it will be J 1.8 per unit. We calculated the fault current. Anyway, consider the magnitude alone. We don't want all the data. We just want magnitude. Next, fault current calculate பண்ணியாச்சு. Fault நடக்கும்போது voltage ஓட value வந்து 1. இப்போ நம்ம fault MVA எப்படி calculate பண்ணுவீங்க? Questionல observe பண்ணீங்கன்னா actual fault MVA தான் கொடுத்திருக்காங்க. Per unitல கொடுக்கல. First per unit fault MVA calculate பண்ணுங்க. Per unit fault MVA level in per unit it will be equal to per unit voltage into fault current in per unit. It will be equal to 1 into 1.8. I am just considering magnitude. Current on the minus J 1.8 only, but I want just magnitude. So that is 1 into 1.8, it will become 1.8 only. There is no doubt. Actual fault MVA வேணும் அப்படின்னா அப்ப என்ன பண்ணோம்? We have to multiply it by base MVA in order to obtain the actual MVA. MVA actual equal to MVA base into per unit. MVA level in per unit calculation. So MVA base எவ்வளவு கொடுத்தாங்க நம்ம questionல? 100 தானே? Yes, it is 100 MVA. This is 100 into 1.8. It will be 180 approximately, right? Yes. So what is the correct answer? Option D. Sir, I have not calculated. See, நம்ம என்ன பண்ணிட்டோம் அப்படின்னா questionல வந்து நான் ஒரே ஒரு பாயிண்ட் மட்டும் தான் எடுத்துக்கிட்டேன். நம்ம இங்க reciprocal எடுத்தோம் இல்லையா 1 divided by 1.1. Actually what will get 0.90909. It will be keep on going. நீங்க 4 digits எடுத்தீங்கன்னா exactly you will get 181.82 வரும் exact value. So option D is the correct answer. That is how we are calculating fault MVA. I hope you all have understood. Okay. So this is all about today lectures. You all have a small confusion in vector grouping. I know. In transformer, once again, we will solve the problems in this vector grouping. Don't worry. I will teach you from the beginning because I know you all have the confusion while developing positive sequence and negative sequence. Actually, there are two type of structures. அதை எப்படி draw பண்றது அப்படிங்கறத many of you know. If you don't know, kindly observe the lectures. Lecturesல point by point நான் நடத்திருக்கேன் எப்படி பண்ணணும் அப்படின்னு சொல்லிட்டு. Though you are still if you are having confusion, don't worry. We are in fault analysis, right? After completing this, we will start electrical machines. There in three-phase transformer vector group connections, I will teach you. I will take some 3 to 4 examples. Step by step, I will teach you. Then you will get the clear-cut idea. You will be able to solve all questions in an examination, right? So with this, let's wind up the today lecture. If you have any other doubts, you can connect through WhatsApp.